Today we're going to go over how to differentiate using the chain rule, the general power rule, and the sum rule. The first step we need is to identify if we have a composite function. A composite function, is going to be d over dx times f of g of x minus, which was going to be the same as f, the derivative of gx times g derivative x. Step 2 is going to be looking and identifying whether the power rule is going to apply. And again, the power rule is going to be u raised to the n is the same as n times u raised to n minus 1 times u raised to the 1. Step 3 is going to be actually applying that if it does, and then step 4 would be applying the sum rule if we need that as well. So right now we're going to focus on using the power rule. So we're going to have an example problem that is d over dx times 2x plus 4 raised to the second. In this case, the first step is going to be for us to take that 2 and bring it down. So we're going to have 2 times 2x plus 4. Now we're going to have to look at the 2, and we're going to have 2 minus 1, which is that n minus 1 up there, which is going to leave us with 1, or we'll just leave it off because that's kind of the just normal state of it. The second part of this problem is going to be finding this derivative of the inside and multiplying by that. So the derivative of the inside, we're going to look at, again, 2x plus 4. 4 is a constant term, and so the constant is always going to have a derivative of 0, and the derivative of the x term is going to be its leading coefficient, so that's going to be 2. So what we're going to be left with here is going to be 2 times 2x plus 4 times 2. Now we can take this 2 and this 2 and we can multiply them by each other, which will leave us with 4 times 2x plus 4. And that is going to be our answer using the power rule. Another example, we will do d over dx times x to the second minus 3x raised to the fifth. First thing we're going to do, get that power down in front. So we're going to have 5 times x to the second minus 3x. Now we're going to do 5 minus 1, so this is going to be raised to the fourth. Then we're going to multiply by the derivative of the inside term. The inside term, we've got x2, so x to the second, we're going to have to apply the power rule to this one, and we're going to get 2x, and then 2 minus 1 is 1, so it would be 2x raised to the first, but don't need to write that. And then for this term right here, we're going to have minus. We just bring the leading coefficient down, so it's going to be 2x minus 3. We write that out so it's nice and clear. We get 5x to the second minus 3x to the fourth times 2x minus 3. And that's going to be our answer for our second example. Our next example, example 3, is going to be a little bit more complicated. We're going to have d over dx times the square root of x to the fourth minus 6. the first thing that we're going to want to do for this is we want to get it out of the root form and into its power form. So we're going to convert that to d over dx times x to the fourth minus 6 raised to the 1/2. Now we can apply the power rule. So we take the 1/2 down in front, x to the fourth minus 6. 1/2 minus 1 is going to give us a negative 1/2 exponent. And then we're going to have to multiply again by the derivative of the inside. Actually, sorry. So the derivative of the inside, we're going to take this x here, x to the fourth, and we're going to bring that 4 down using the power rule. We get 4x, 4 minus 1 is going to be 3. So 4x to the third minus 0, because the constant is 0, which leaves us with 4x to the third, which we're going to pop back in over here. All right, continuing on, we're going to rewrite as 1/2 x to the fourth minus 6 raised to the negative 1/2 times 4x to the third. So we are going to multiply this 2 times x to the fourth minus 6 times the 1 over here, because we need to get rid of this negative here shortly. So that will leave us with an equation that's 4x to the third over 2x raised to 2 times x raised to the fourth minus 6 raised to the 1/2. Sorry, I didn't add that up there. We are almost there. This looks pretty good, but we want to convert this back into its root form. So we're going to do that. Now we have 4x raised to the third, and then we have 2 times an exponent of 1/2 is the same as saying the square root of. So square root of x raised to the fourth minus 6. So now we have it back in its radical form, which is our final answer. Our final example, we're going to use the sum rule, and we're going to apply the sum rule in order to find the slope of our tangent line at a given point. So we're going to add a little bit extra here. So we're d over dx times f of x plus g of x is going to be equal to d over dx times f of x plus d over dx of g of x. Sorry, that's a little squished looking. So we're going to find the slope of y equals f of x at the given point. And our point is going to be 0, 11. And this is our expression here. We're going to have x raised to the 10th plus 5 plus the square root of 36 minus x. So we're going to need to take each one of these parts and break them up to be able to find their derivatives individually, and then we will add those back together in order to be able to solve this equation and simplify it. So the first thing we're going to do is we're going to put d over dx, and we're going to multiply that times x to the 10th. That's going to be plus d over dx times 5 plus d over dx times the square root of 36 minus x. We're going to take part 1, and we're going to apply the power rule to be able to answer this. So the 10 comes down here. It becomes 10x. 10 minus 1 is 9. So 10x raised to the 9th. And we're going to multiply that by the derivative of the inside. The inside is x to the 10th. Our leading coefficient on that x is a 1, so it's going to be times 1, which is pretty easy. So we get 10x raised to the 9th as our derivative for that first term. Our next term is going to be the derivative of the constant, which is 5. Doesn't really matter what the constant is because the derivative of the constant is always going to equal the same thing, and that's 0. So this is our final answer for the second term, and we're going to have our last term, which is the derivative of the square root of 36 minus x. So to be able to solve this, again, we need to be able to put it in exponential form. So it's going to go from the square root of 36 minus x to 36 minus x raised to the 1/2. Now that we've done that, we can apply our power rule. We're going to take that 1/2 down in front. 36 minus x. We have to take 1/2 minus 1 because that's our power rule. So we get a negative exponent once again, just like in the previous problem. And we're left with 1/2 times 36 minus x raised to the negative 1/2. We need to multiply that by the derivative of our constant, by the inside, the derivative of the inside. So 36 minus x. 36 is our constant, so the derivative of that is 0. And then our leading coefficient right here for the x is going to be negative 1. So 0 minus 1 is equal to negative 1. So we're going to multiply this whole thing by negative 1. Which means that we're simply going to change the sign on the remainder. So we have negative 1/2 times 36 minus x raised to the negative 1/2. At this point, we're going to put this, we're going to have to take our negative sign and deal with that because we don't want negatives in the exponents. And so we're going to make this the reciprocal of what it is. So we're going to have 1 over 2 times 36 minus x raised to the 1/2. So we no longer have a negative exponent, which means that we can go backwards and take it from exponential form back into its root form. So we do negative 1 over 2 times the square root, because the 1/2 exponent becomes square root of 36 minus x. All right, so that is our last term. This is the answer for our last term. So to recap, we had 10x to the ninth for our derivative of the first term. We had 0 for the second term. And we have negative 1 over 2 square root of 36 minus x for our last term. Now we need to get our sum. So we take 10x to the ninth plus 0 minus 1 over 2 square root of 36 minus x, which gives us 10x to the ninth minus 1 over 2 square root 36 minus x. This is going to be our problem differentiated. However, this particular problem that I chose added an extra step where you need to figure out what the tangent line is. The slope of the tangent line on the given point is what we originally did. So if we recall, our given point was 0, 11. We have our x terms, and so x at our given point is 0. We just need to take that 0 and plug it back in to get our final answer. So we have 10 times 0 raised to the ninth minus 1 over 2 times the square root of 36 minus 0. Not that bad. So 10 times 0 raised to the ninth, anything times 0 is going to be 0. So we get 0 minus 1 times 2, square root 36 minus 0 is going to be 36. So now we have negative 1 over 2 times the square root of 36. The square root of 36 is going to be 6. So our final answer is going to be negative 1/12. So the slope of our tangent line at the given point is negative 1/12. Thank you very much. That's how we differentiated using the chain rule, the power rule, and the sum rule today, and how we applied that to be able to find the slope of the tangent line at a given point.